Introduction. What is the composite? The composite is a composed of two or more individual materials which come from metals, ceramic, and the polymer. Then they have a few properties of the composite. The first one is the tensile strength of the composite. The tensile strength of the composite is 4 to 6 times greater than the conventional materials like the steel and the aluminium. The second one is the composite are more versatile. The composite are more versatile because it can be tailored to meet performance needs and the complex design requirements. And the last one is long-lasting. The composite offers long-lasting time because it has excellent fatigue impact, environmental resistance, and reduced maintenance. For example of the composite is the carbon fiber, mud brick, and the fiberglass. And now we are moving to type of the composite. There are 3 types of composite material. The first one is the particle reinforced. The particle reinforced are composite in which the particles are condensed together to form the integral mass. For the example is the cement and the concrete. The second one is the structural material composite. The structural composite is the laminated material that are products made by bonding sheets or materials together. Furthermore, it usually applies the greater heat and the pressure. For the example is the plastic and the glass. And the lastly is the fiber reinforced. The fiber reinforced material, the reinforced material are the material which are produced by combining some suitable material to provide additional strength which does not exist in a single material. Fibers are usually used in a concrete to control plastic shrinkage cracking and dryer shrinkage cracking. For the example is the reinforced cement concrete, which is RCC, and glass fiber. Besides that, they also has lowered the permeability of concrete and thus reduce the water.
For the method or the process involved in the composite, there was a two-way. The first is the metric phase. Metric phase is to tie the fibers together so that the stress is applied spread across the fibers. Second, it also shields the surface of the fiber from being damaged. And lastly, it also isolate the fibers and prevent the spread of a crack. The other way is the dispersed phase. The reinforcement is typically much thicker and stiffer than the metric, and this gives the composite positive property. In addition, the metric keeps the reinforcement in orderly pattern, and the metric also helps to move the load between the reinforcement. Exceptionally, the reinforcement comes in 3 forms, particularly metal, discontinuous fibers, and continuous fibers.
There are many reasons for the growth in composite application, but the primary impetus is that the product fabricated by composites are stronger and lighter. Today, it is difficult to find any industry that does not utilize the benefit of composite materials. In the past 3 to 4 decades, there have been substantial changes in technology and its requirement. This changing environment created many new needs and opportunities, which are only possible with the advance in new materials and their associated manufacturing technology. Broadly speaking, the composites market can be divided into the following industry categories, which are aerospace, automotive, construction, and marine. In aerospace, the composites application offers several of these features, which are: number 1, it is lightweight due to the high specific strength and stiffness. Number 2, fatigue resistant and corrosion resistant. Number 3, the capability of high degree of optimization, tailoring the directional strength and stiffness. And number 4, the capability to maintain dimensional and alignment stability in space environment. Moving on to the composites component. Now, for passenger aircraft such as the Boeing 747 and 767, use composite parts to lower the weight, increase the payload, and increase the fuel efficiency. The components made of composite for such aircraft are shown in the slides. For example, the cargo floor panel made of fiberglass or aluminum, the air conditioning duct made of fiberglass or the BMI, and the nacelle, which is made of carbon fiber or aluminum honeycomb.
Ultimately, 1/3 of marine applications are now made of composites. Why? This is because the first one, it has low maintenance requirement, which is low life in cycle cost. The second one is it has high specific material properties, which make the composite materials attractive for submarine and submersible structures. The third one, it has geometric flexibility and it also has good moisture stability. There are several composite components in a marine application. The first one is carbon fiber composites. Usually, carbon fiber are combined with other materials to form the composite. For example, combination with a plastic resin and molded it to form carbon fiber reinforced plastic, which it has a very high strength to weight ratio and it's extremely rigid although somehow brittle. The second one is glass fiber composites. It is first used in marine applications and also revolutionized in marine industry. It can be founded in a variety of boats and vessels. The third one is bamboo structural composites. Bamboo composites exhibit excellent resistance in a marine environment and their applications could make good inroads in the marine sector worldwide. Fire-safe phenolic composites material, which is phenolic resins, are well known for their excellent resistance to heat and combustion. However, it needs extreme processing conditions. Fiber reinforced polymer (FRP) composite are used instead of timber, which was traditionally used in small maritime craft because the wood was become increasingly expensive. Last but not least, wood plastic composite marine board, which is a composite materials alternative to timber for pontoons, docking stations, jetties, walkways, and similar applications.
For the conclusion, in recent years, the developed countries use advantage in the field of materials and engineering technology. The application in the field of composite materials in the sporting goods expand increasingly, has made remarkable achievement. Currently, cycling has become a trend during movement control orders since the last year. As is known to all, before the advent of fiber-reinforced composite is not, like sport equipment materials, mainly wood, stainless steel, and aluminium alloy. Compared with these materials, the fiber-reinforced composite materials has obvious advantage in some aspects. One of the advantages is light. Most of the sport equipment is to rely on human to move. The lighter the better. Therefore, require equipment such as bikes. Fiber-reinforced composite in this aspect has incomparable advantage. Composite material has a good damping shock absorption performance. Is also one of the reasons it is a raw materials for sport equipment. The future of composite materials in the sporting goods industry looks attractive with opportunity in bicycle application. The composite materials market in the sporting goods industry is expected to increase from 2018 to 2023. The major drivers for this market are the increasing use of lightweight and high-performance materials in sport equipment. Here are the references that we use in our study. That's all from us. Thank you so much.